Welcome everyone. Today we're going to talk about software defects and how defect management plays a crucial role in delivering quality software. A software defect is essentially an error or bug that causes the application to behave unexpectedly or incorrectly. Managing these defects efficiently is key to maintaining smooth development and ensuring user satisfaction. For example, in Agile Scrum, defects are often tracked and prioritized within the product backlog, and teams work on them during sprints alongside new features. This helps catch and fix issues quickly while keeping the development process flexible. The images here, such as the visual of a bug interacting with a computer, humorously represent the concept of software defects, reminding us that these bugs can disrupt systems if not properly managed. With that basic understanding, let's dive deeper into how defect management frameworks and tools help us keep software reliable and efficient. When a test is running and the actual outcome doesn't match what we expected, that's when a tester raises a defect. A defect, which is also called a bug, refers to any error, flaw, mistake, failure, or fault in the system that causes it to produce incorrect or unexpected results, or to behave in ways it shouldn't. Before logging any defect, it's important to follow certain guidelines. First, make sure to assign the correct priority based on how much impact the defect has on the system. Then clearly write down the steps to reproduce the defect, including what actually happened and what you expected to happen. Attaching relevant screenshots is essential, so highlight the issue clearly, include timestamps and any log files that can help with troubleshooting. It's also important to link the defect to the correct test case ID and, if possible, reference the specific requirement that relates to the defect. When retesting, close the defect only if the same steps confirm the issue is fixed. Raising valid defects is crucial for improving software quality. This process is also well aligned with agile methods like Scrum, where defects are quickly reported and prioritized in backlog grooming sessions, ensuring they are addressed in upcoming sprints without disrupting the flow. When categorizing defects, it's important to assign priority based on how much the defect impacts the system's functionality. A critical defect is one that completely stops a function or process from working and needs an immediate fix. High-priority defects are serious malfunctions that prevent a function from executing properly, but may not be as urgent as critical ones. Medium defects are deviations from the specifications that don't break the system's core workflow and usually have a workaround available. Low priority covers minor issues like cosmetic errors or documentation mistakes that don't affect the system's operation. In Agile and Scrum environments, teams typically triage these defects during sprint planning or backlog grooming sessions, ensuring urgent bugs are addressed in the current sprint, while less severe ones can be scheduled for later. This way, developers and testers focus on what impacts users most, balancing fixes with ongoing feature development. When we talk about defect priority and severity, it's important to understand how they differ and how both influence handling issues in testing. For example, if an ATM is not printing transaction receipts and throws a system exception, that's a high severity defect because it breaks a core function, and it also has high priority since it needs immediate fixing. On the other hand, if the transaction receipt shows incorrect information, it's still high severity because it affects accuracy but low priority, since it doesn't stop the process and can be fixed in the next release. Sometimes a defect might have low severity but high priority, such as a typo in the customer's name on the homepage title. The issue isn't critical technically, but it's important to fix quickly to maintain customer trust. Finally, a minor UI inconsistency like a title not being italicized or bold as per design guidelines has both low severity and low priority because it doesn't impact functionality or user experience significantly. In Agile and Scrum environments, identifying these distinctions helps teams prioritize their work effectively during sprint planning, ensuring critical problems are resolved first while less urgent defects are scheduled appropriately. This approach keeps the product stable and maintains customer satisfaction simultaneously. When a defect is identified, it first gets assigned to a relevant team member for investigation and fixing. Sometimes, if the defect is better handled by another person or team, it can be reassigned. Once the fix is made, the defect is retested, and if everything works correctly, it is marked as passed. Before this, during the triage phase, the defect is reviewed to decide its priority and the best course of action. In agile environments like Scrum, this cycle is integrated into sprint planning and daily stand-ups, so defects move quickly through these stages, keeping the development process efficient and responsive to issues as they arise. When you find a defect during testing, you mark it as new and assign it to a developer. Then, the defect goes through a triage meeting where key team members like the development lead, test manager, business analyst, test lead, and testers review and approve it. Depending on the defect's nature, the team may reassign it to the right person. Once the developer accepts it, the defect status changes to open. If the developers or triage team find that the defect is not valid, it gets rejected, and the tester closes it with an explanation. Sometimes, if the defect is the same as an already reported one, it is marked duplicate, and the tester closes all duplicates with comments. If a defect cannot be fixed in the current release, or it's beyond the project scope, it's deferred by the triage team. This process helps keep defect management organized and efficient, much like how Agile Scrum teams regularly review and prioritize bugs during sprint planning or backlog grooming sessions to ensure timely resolution and clear communication across the team. When a developer or triage team member feels unsure about a defect, they change its status to clarification needed and send it back to the tester for more information. If the tester provides the needed details and confirms it is still a defect, then the defect is reassigned to the developer with an open status. However, if the tester determines it is not a defect, they close it. For defects marked as fix, the developer investigates and debugs the issue, and if the defect behaves as expected after correction, they update the status to fixed. The tester then picks up all fixed defects for retesting in the next release. If the defect is still unresolved during retest, the tester reopens it and assigns it back to the developer. Finally, when the defect passes all tests, the tester closes it, marking the defect lifecycle complete. In Agile Scrum, this workflow is often embedded within sprint cycles, with constant communication helping to clarify and resolve defects quickly, ensuring smooth and continuous delivery. Each defect recorded in the system is tracked using a standard template to ensure consistency and clarity. The defect ID is automatically generated by the defect tracking tool, making it easy to reference. The project and component fields specify where the defect was found, along with the version of the application in which it occurred. It's important that testers accurately specify the testing phase when the defect was detected because this helps prioritize fixes. The summary should be brief but clear, giving an immediate idea of the issue, while the description provides detailed information to understand the problem fully. Test steps are listed in order, numbered to show exactly how to replicate a defect, which helps developers reproduce it quickly. The actual result is the problem observed during testing, contrasted with the expected result, which is how the system should behave. Attachments like screenshots or logs can provide additional context, and remarks allow for any extra comments that might be relevant. Defect severity and priority are crucial because they guide how quickly the issue should be addressed, reflecting the impact and urgency. The tester who found the defect is recorded in the reported by field, and the assigned to field shows who is responsible for investigating or fixing it. Lastly, the status tracks the defect's current stage in the workflow. In Agile Scrum environments, this template supports clear communication during sprints and daily stand-ups, helping teams rapidly identify, assign, and resolve defects while maintaining transparency across developers, testers, and product owners. When developing a test strategy, It's important to estimate all the testing activities carefully, starting with writing detailed test cases and scripts that cover the application's workflow and functionality. Once the test cases are prepared, they need to be reviewed alongside any change requests, and feedback should be given to both the business analyst and development teams to ensure clarity and accuracy. Identifying dependencies early allows us to take the necessary steps to address them, which helps avoid delays later on. Coordination is key. Working closely with the entire team, we provide clear guidelines for testing so everyone understands their roles and responsibilities. Preparing test data for every testing phase ensures realistic scenarios and comprehensive coverage. It's equally important to track and monitor release notes to stay informed about changes that might affect testing. As defects are found, reporting them promptly and creating detailed defect reports helps keep everyone aligned on issues. Testing progress must be communicated regularly to the project manager, and any roadblocks or risks should be escalated right away for timely resolution. Finally, delivering all testing-related documents completes the process, supporting transparency and ongoing project success. In agile environments, this approach fits naturally with sprint cycles, where testers continuously create and update test cases, participate in sprint reviews, and quickly react to defects as they're discovered, ensuring the product stays on track with iterative development. When we look at quality process metrics, several key indicators help us keep track of defects and overall testing effectiveness. First, monitoring open defects by severity shows us which issues are most critical and need immediate attention. Breaking this down further by functional area or release helps pinpoint where the problems are concentrated, allowing the team to focus resources effectively. Defect aging tracks how long defects remain unresolved, which is important to avoid bottlenecks. Test coverage planning and execution status by functional area or test cycle give insight into how thoroughly the product is being tested and where gaps might exist. The defect rejection ratio tells us how many reported defects were invalid or duplicates, helping improve defect reporting accuracy. Test productivity measures how efficiently the testing team is working. Tracking defect identification in pre-production versus production environments indicates the effectiveness of our testing before release. Weekly defect rates by environment and the defect escape ratio help us understand how many issues slip through to later stages. Analyzing defects by the phase they were found or their origin by functional area gives us a clearer picture of where improvements are needed in development or testing. We also look at the percent of tests that are automatable and track automation progress and coverage, since automation plays a big role in speeding up testing and reducing human error. All of these metrics together provide a comprehensive view of product quality, testing effectiveness, and process health. In Agile Scrum teams, for example, these metrics are regularly reviewed in sprint retrospectives to quickly adapt and improve, ensuring defects are caught earlier and quality standards are consistently met. Feel free to ask any questions you have about the defect management process we discussed, whether it's about detecting defects during testing, triage meetings, clarification steps, or using defect templates. I'm also happy to explain how these practices fit within Agile Scrum, such as how defects are prioritized and assigned quickly in sprints, or how communication between testers and developers helps keep iteration smooth. If you want, I can provide examples of how defect metrics guide quality improvements or how test strategies align with delivering reliable software. Just let me know what you'd like to dive deeper into or clarify.